coming to this point, it is very sure that sustainability is not a word, it is not a buzzword right now. It should be a way of life, because the thing is, we are not inheriting the whole earth from our parents. It is we are borrowing from our children. And certainly to make their children brightful and make them healthier and live longer, we should do something. We should not exploit this Mother Earth for merely utilizing our benefits and solving our purpose. So sustainability is a big part, and among a very teeny bit of that is what I'll be talking and speaking about today. I'll be talking about the motors which are present everywhere in and around us. The electrical motors are present in the mining industries. They are present in the utilities and the power generation, where either it is NTPC, IOCL, PGCIL. They are in the process industries, where all the steel, paper industries and all these industries, they use electrical motors. Oil and gas rigs, all these utilize electrical motors for their extraction. Transportation and logistics, this is also one of the applications of motors. Last but not the least, which has come up in the near future. I should not say it has just come up in the near future. In the EVs field, electric vehicle field, it started in 1830s. But now, because of some of the slides which my previous presenter has showed, Kyoto Protocol has been there, and because of that, whole scenario of the global scenario has changed. And we are now slowly and gradually shifting from petrol and gasoline kind of products to batteries. So what's new and how predictive maintenance is coming over here in electrical motors? So in all the applications which I told earlier, we had different kind of applications, different kind of environments, and subsequently different kind of anomalies also, right? So the different kind of challenges which we usually face with electrical motors are thermal stress, because in due rotation of continuous operation, some temperature of ambient temperature is there and the temperature of the windings are there, so the gradual temperature rise is there, and that causes some of the other thermal stresses over the winding and the insulations, which with due course of time are going to deteriorate. The other is wear and tear, the bearings and all those, they are going to deteriorate. Now, when the sudden downtimes are there, they cost heavily on us, right? So even in Bangalore nowadays, it is a scenario of AC. Other Bangalore was a city of rooms without fans. Then slowly and gradually fans came. Now even in a scenario in a Bangalore, in a common place where a fan is not running in a summertime, we face very heavy kind of situation. The scenario is even worse in Delhi and NCR, in Jaipur. So what we pay in terms of time, in terms of comfort, in terms of finally cost. And the final one more stress is the vibration. So ultimately it should be running on a particular kind of point, but due course of time some problems are there and the vibration stresses are also there. Now since the electrical motor has been used in industries and humankind has been using them since long, the anomalies have also been since long, and it is not like that the human beings or we people or our seniors and ancestors or researchers have been sitting quiet for that. They have been doing some kind of approaches to eliminate these kind of problems. So the first kind of issue which was used by earlier kind of engineers or researchers or the people who were facing such kind of anomalies were corrective kind of issues. Once the problem is there, we used to check what the problem is and we used to rectify that problem. So correction is based upon reaction. Some action is there and based upon that you react. How you react is based on the action. So the next was preventive. So the preventive thing is something like the scheduled kind of maintenance is there. After every 14 days, 1 month, 3 months, depending upon the duration or the life cycle or the duty cycle, how you use your motor, these maintenance periods grow on. Last but latest, in some period, we are coming up with a common thing called predictive maintenance. So it is how you predict the future. You are going to predict before the fault is or the anomaly is going to happen. So here, the whole concentration of the electrical mobility, either in automobile, road segment, off-road segment, highway segment, either in air, land or sea, we are using these kind of scenarios for the prediction of motors future. Now, comparing all these three in the terms of time and the degree of advancement, we can see that the corrective action was taking a lot of time and cost. It was less advanced, only some kind of specialization was required for eliminating a particular kind of fault or disturbance in a motor. Second was the preventive one. It used to cost less, but it again took some time. The last one is what we are facing right now. It is the predictive one. So it is having the least kind of cost burden on the industry or the users or the end users customers, and it is the most latest techniques which we will be coming up in the next slides are being incorporated over here. The traditional approaches which I have mentioned in the first two part are, the first one is the corrective. We used to fix after some failures are there and the high downtimes are there. The other one is preventive, schedules are there. The common base, or you can say negative of both of these, is that both of these have high cost, and the cost is not only usually in the terms of money or dollars, it is most of the time our time also, because time is the precious thing, and if we are losing our time, it's somehow somewhere going to cost us dollar or money or something. So next comes what we are going to talk about today. It is the predictive maintenance. The predictive maintenance is not a single kind of single shot, one arrow, one bow and one bullseye kind of thing. There are many approaches, many seeds, many plethoras, many islands over there on which we can have this predictive maintenance kind of thing. One of them is the vibration and acoustic one. Predictive maintenance can be based on the vibration. If the motor is vibrating or some acoustic vibration or sounds are there, we can have the analysis based on that. We can have analysis based on the temperature of the surface or the stator or inside the motor, outside the motor. We can have a motor current signature kind of analysis, because usually all the motors are electrical motors. They are supplied with electricity and the current is going to be feeding these motors. So based on these, we are going to find the anomaly. And last not the least, with the recent, nowadays the trend is going on AI and ML. Recent trends which we are daily new, some algo is coming up for these kind of ML kind of architecture. So these are some of the methods which are nowadays being used. And it is not also like that any one is sufficient or any one is best, or with any one I'll be getting the best one. A combo of any one of these, any two of these or three of these usually gives the best answer, and the best answer is dependent upon the type of application, the application environment, and how the drive cycle of that motor or the application is there. Coming one by one, I understand that the time is very short since we have been delayed. I'll be very fast and quick on these. The vibration detects the mechanical issues. It also has the wireless sensors which detects these kind of things. It provides the real-time kind of analysis, and this is what the vibration sensor-based predictive analysis is going for. The disadvantage is that it is very sensor sensitive. If any kind of slightest upper side or lower side error, somewhat error is there, it will give you a good motor, will give you a bad motor kind of thing, or a bad motor will give you that it is a good one. So this is a bad part of that. False predictions are there. Acoustics is the next one. Acoustics is based on the vibration part. It detects structural changes, what kind of faults it can detect. Structural changes are there. If a motor is there, it has some cracks on the bearing, shaft, on outer surface, the sound or the vibration that we hear, it will be somewhat different. It won't be audible to us, may be beyond our audible range, but somehow those sensors are going to capture it, and those mathematical functions are going to derive that these kind of cracks are there. They are non-intrusive and they are a very high sensitive kind of thing, but again they have some disadvantage. They can be very expensive to implement because I said a particular kind of frequency band, audible band has to be not audible, some sound band has to be captured, and depending upon that sound band, they calculate all these kind of things. The next one is the temperature analysis. Temperature, usually there is a common kind of threshold level, there is a common upper level. In between base and the top, usually all things operate. Either it is the behavior of a human being, the temperature of this room, the light and the ambience of this one, or anything. They have some lower and the upper limits. Likewise are the temperature limits for a motor. They have a lower and upper one, so a temperature sensors are required. They are usually identifying the critical windings and the bearing faults. They are usually used to prevent overloads, because whenever we are subjecting any motor to an overload, excessive current is being drawn, and a very basic kind of thing, class 10, 11, 12 I square RT is there. So more the current, maybe the resistance remaining same, with due course of time the heat is going to increase. So the stress increases and the thermal sensors are being used. The disadvantage for this one is that it requires constant calibration. So that is again a kind of disturbance or hindrance to us. Now the basic physics models are used to design motors since long, since they were DC. So earlier, all of you might be knowing or not, the first motors were DC. Then came a war between two big scientists, whether it should be AC or DC, and finally AC won. AC is right now going on, and AC has many disadvantages, many history kind of things are there. And all those, either it is a AC kind of motor or DC kind of motor, current is being supplied to a stationary part and some rotation is there at the other part of the motor. So this technique persistently defines on the physics base how the currents behave, what is their shape, what are any harmonics or fundamental differences in their normal behavior or an abnormal behavior. This method is for that. This is a non-intrusive method. This detects faults much earlier before it is going to happen, because it is just the physics one, how the current is going to behave in the air gap, and it is the advanced technique. Very advanced techniques can be used, like mathematics, if we people remember FFT, HST and all those kind of fundamental things can be used over here. The disadvantage is the calculation requires calculation is very fast, very vast, and for all those matrix equations, it is usually 6 by 6, 36 by 6, 36 kind of matrices. So computer memory, all those requirement, RAM and all those, it is very large. Last, the latest one which has come up in this one to help everyone is the AIML. AIML has been a kind of thing which is shaping the future to each and every field. Either it is a cloth industry, lighting industry, media, health, or obviously engineering. So engineering, one of the is electrical, one of the application is motor. AIML is there also. AIML is used for the predictive maintenance. Predictive models are being used, various kind of models are there. Inbuilt, we can use one of those. These models are self-learning. It can also be like that, you have a certain kind of past data, you can train on them. Then with due course of time, these software, all the programs get on updating themselves. And they are up to date till date. So that is a good part of them. They have complex data analytics, because if you simply remember ANN or RNN or CNN kind of architecture, some hidden layers, some feed forward, backward, all these kind of structures are there. So complexity is there. So the biggest disadvantage of ANN is not that this complexity, it is something like that to work upon on these AIML need a lot of data. And data is the key. Data is where this modern industry is running on. If you have the data, which right now we were discussing with one of our friends, if you have data, you are the king. or if you move it around, if you have the data and you know how to use, you are the king. So that is the thing we recalled some time earlier only. So huge amount of data is required. And many people, many seniors and previous speakers have talked upon this stage about SDV, big data, and all those kind of things. So all these things are very right. Some questions were also there. But one thing is very sure, whether I'm talking of AI, ML, SDV, or whatever, where this data is going to be stored. And if right now the penetration is 5, 10, 20%, what will happen if the data penetration or the EV penetration 80%? Where will this data go and how the security is being there? This was discussed in the previous forums. I was just highlighting those parts. So this is just a comparison of the previous, all those methods which I had talked upon. Some pros and cons are there, what kind of faults we can analyze on which one, and why the complexity of which one is better upon whom. This is a comparative table. I won't be elaborating because I explained somewhat earlier. The benefits of predictive maintenance, which is the main topic that I'll be telling on, it reduces your downtime. Why downtime is being reduced? Because before the fault or any anomaly is going to happen, you are going to know, a Ramesh or a Shilpa or Anil or whosoever, your motor or EV or whatever your industry or your home, oven, microwave, wherever, refrigerator, anywhere your appliance is going to have a troubleshoot. Kindly rectify, kindly go for a maintenance. And believe me, this kind of maintenance usually takes 10% of the time and 10% of the real cost when the fault has occurred. So before the fault has occurred, if you go for such kind of maintenance, it will reduce your number one time, number two the cost. So both of these, the reduced downtime is there. Since the motor is not subjected to extremes, those two extremes are told, everything it is temperature, pressure, humidity, psychology, everything. If you cross this upper limit, you break one breach, one layer is there. More the breaches, more the life is reduced either for a human being, likewise for a motor. So if you are not reaching that limit, you are in between correcting it, lifespan increases, maintenance costs are obviously reduced, and the reliability obviously is increased because we are getting to know everything in before it is going to happen. Now it is not like that, everything is goodies for predictive maintenance. Everything has some pros and cons, whatever you say in this real world. So some of the things are, they need high investment. They need very specific kind of sensors. These sensors are very costly. If I talk of very technically, ADC. Right now ADC you can get in 20 rupees also, and the ADCs that we are working on can be working for some 20,000 or 30,000 also. Some depends upon what kind of specification and purpose you are using for. So it requires skilled manpower for designing those physics equations, for all those kind of vibration analysis. Some particular subject matter expert has to be there, which will tell you, okay boss, aisa ho raha hai, so it should be like that. Some precedents should be set up by some skilled persons. Integration with the legacy kind of system should be there, but it is right now because slowly and gradually the industry is moving from 3 to 4, and somehow we will be moving to other, means 4.0 I was talking of. Now most of the companies are trying to get 4.0, they are not yet 4.0. So we are talking of somewhat more ahead. We are talking of data, plenty of data, much data, real time, every time available. So that is far ahead of that. So that also becomes an issue. Data quality and consistency, again, which I told, the data importance is there, and the whole predictive maintenance works upon data, data and data. So this is again that kind of thing. So the future, where will the future of, what is the future as far as predictive maintenance we can say? The AI driven diagnostics can be there. We can use different kind of structures, programs, algos. Sustainability focus is there, which I initially told accessibility is the whole planet. I am talking of a pinpoint. So this pinpoint is concentrating to this motor. Digital twins, which was also talked about in the previous lectures. Digital twins, rightly coded by one of my friends. Digital shadows are also there. So either it is digital twin, digital shadow, whatever. Both of these are some of the things. IoT, all the data has to be real-time uploaded to the cloud, and the cloud is going to make it secure, make it assigned to the real kind of person, authentic person for doing the authentic kind of work. And the 5G integration, 5G nowadays, later on 6G and so on. So one more thing is that which I told earlier, there were some kind of hot topics for predictive maintenance. One was MCSA, one of them was AIML. I told none of them is the best. We cannot say one of them is the worst. It is a combo of these depending upon the kind of application and the kind of environment, drive cycle it will become. So this is the best kind of feature that we have been working upon. It is an integration of mathematical physics models with AI/ML compatible models. The advantages, advanced fault diagnostics are there, and the early warnings are there. Machine learning algorithms are getting updated daily depending upon whatever kind of use cases you have. And the disadvantages are they require substantial computational power because data, information, knowledge, wisdom, that's a long chain. We are right now in the world of information only, that's AI. Then, so it's a game of only data and becomes a very heavy intensive in the terms of cloud and all. The integration of AI MCSA is also the advanced algorithms are being used. Some of those who are familiar with this kind of industry must be knowing LSTM, RNN and all these kind of functions which are there. The anomaly prediction becomes fast. The time series analysis is somewhat tough as compared to the previous one. So this is some of the application which or things that I can say predictive maintenance has been using or is coming up. I'll give a stop over here. Nothing to make it more broader and extended. Just the thing is, only one thing we should remember, either it is a motor or my life or yours or my appliance or yours, use it with some kind of sense and dignity. I do not say that we are not using with dignity. Dignity in the terms of when you are thinking of your future. It's not your future, your children and your children's future. Thank you. Have a nice day.